Hello, and welcome to this presentation of Oracle 11G PL/SQL Programming Part 1 using SQL statements in PL/SQL blocks. My name is Mary Gable, and I will be your instructor. If at any time you have any questions, please don't hesitate to use our question and comment box that you're going to find located at the bottom of your page. Now, let's get started. Topics for this particular module include, we're going to talk about selecting data from the database into our PL/SQL variables. So we're going to be concentrating on what we call the into clause, which is part of our select statement. We're going to be embedding SQL in our PL/SQL blocks, for example, the select statement. And then we'll have an exercise and an exercise review to practice these concepts. Now, when we select data from the database, we actually have to have a place to put that data. And so PL/SQL requires that we select information and place it into PL/SQL variables. In addition to the select statement, you're also able to issue DML commands from PL/SQL. Of course, DML commands include your insert, update, and delete. You can use the returning clause on any of these statements to return values after the DML operation. And finally, you can use the transaction control commands in PL/SQL, such as commit and rollback. Now, the select statement itself, it's a SQL statement. It's used to retrieve data from the database, and it's oftentimes referred to as a query. Within a PL/SQL block, whenever you need information from the database, a select statement can be written. That select statement is going to require an into clause. The into clause is going to indicate which column values are placed into which variables. The into clause immediately follows the select list, and again, is used to hold the variable list that will hold the values that are being selected. And here's a picture, of course, of what that might look like. If you select columns in a query, the next clause that you will have is the into clause. And so the columns are going to map one-to-one between the columns being selected and the variables that have been declared and are waiting in the into clause. Now, these variables that you reference in your into clause, they may be scalar or composite. Now, when you're retrieving values into a scalar or a record variable, you must be very careful that you return only a single row. Otherwise, if you return either 0 rows, an exception is going to be raised. That exception is called no data found. And the other thing that could occur is you could have more than one row. And if your select statement returns more than one row, you'll actually get another exception that's raised. This one is called too many rows. And that's an indication that what you need is a cursor. So if you're writing a select statement in your PL/SQL block, and that select statement is intended to return more than one row, you are required to use what we call an explicit cursor. Now, until we get to the point where we talk about these cursors, when you're practicing PL/SQL programming, you're going to need to be careful that when you issue a standalone select statement, that you're returning just a single row. So what that means is you could use the primary key in the where clause. You might also select a group function without a group by clause, such as select count star from imp. As long as you're sure that you're returning only a single row, you can have these what we call standalone select statements directly in your PL/SQL blocks. SQL functions are also supported. You might have SQL functions in your select list. You might also reference them in your where clause. In addition to SQL functions, any user-defined function that you write may also be called, and many can be used in other procedural statements such as assignment statements and directly in other PL SQL expressions. Now the into clause, that's what's going to specify exactly which variables are populated with the results of the query. And again, they're going to correspond one-to-one. The variables were going to correspond to the columns in the select list based on position. And of course, since we have to declare variables to hold column values from the database, don't forget about percent type anchoring that we've talked about in previous modules. This is an excellent opportunity to use percent type when you declare these variables. Now, if you need an entire row out of the database in your PL SQL programming, or almost the entire row, consider using a record variable based on the table and declared using percent row type. Oftentimes when we need to declare individual scalar variables for every column, we end up having many variables to have to keep track of in our programming code. So it makes it a lot easier to use a record. Then, if you've declared a record in your into clause, you must only reference that one record variable. Now, PL SQL does not directly support DDL statements. And of course, by DDL statements, we mean create, alter, drop. Okay. Another thing that's not directly supported is dynamic SQL. The fact of where you're actually building your SQL statement at runtime. We do, however, have the execute immediate command, and that command can be used to dynamically construct SQL statements and also can be used to execute DDL statements that are otherwise invalid as a standalone statement. There's also a package, DBMS SQL, that you may also use, and it provides capabilities for performing dynamic SQL as well. It's actually an older way of doing it, and once PL SQL added the ability to use the execute immediate command, it's now recommended that we use that over the package. It's just much faster and much easier to program. Now let's take a look at this PL SQL block. You'll notice, first of all, there are two variables here being declared. One's called VENAME, and it looks like the ENAME column in the IMP table using the percent type anchoring. We also have VDNAME, which looks like the DNAME column in the department table. And again, percent type is the attribute we use for that. Here's begin. This is going to signal the beginning of the block. And the first executable statement that we have here is a select statement. You will notice in the where clause, it's looking for a particular employee number. And it's doing that using the ampersand. And that's something that SQL Plus will prompt you for. So when you execute this PL SQL block, SQL Plus is going to prompt you for a value for employee ID. And you can enter in any valid employee number and have this block execute for that particular employee number. Now what your select statement is going to be doing is it's going to be selecting the ENAME from the IMP table and the DNAME from the department table into the two variables that we declared above from the IMP and the DEPT table. This is actually an example of a simple join that's being performed here. And the join condition is where the department number in the employee table is equal to the department number in the department table. And then, of course, we need to be careful that we're only getting one row. Therefore, this AND condition is going to ensure that we are looking for a single employee number. Once the select statement executes, these two column values are fetched and placed into these two variables here. So once the select statement completes, we now have a name in our VE name column and a department name in our VD name column. And so we're very simply going to print out a message that says employee, and we'll put their name, and then the string department, and we'll print their department. Here you have the end semicolon that ends the block, and finally the slash that executes the block. Now let's take a look at an exercise using SQL and PL SQL blocks. What we'd like for you to do in this exercise is to write an anonymous PL SQL block which will select the average and the total salaries for all employees in Department 10. Once you've retrieved that, we'd like for you to display the information to the screen using DBMS output.putline. The specific steps that you will need: first of all, you'll need to declare two variables. You're going to need one that's going to hold the average salary, and then you're going to need another one that's going to hold the total of the salaries. In the body of your block, you're going to need a select statement that's going to select, and of course use the SQL function sum and average. So you'll select the sum of the sal, comma, the average sal from the employee table where the department number equals 10. And then finally, once you've retrieved that information from the database, print out a message to the screen using DBMS output.putline and simply say the average salary for Department 10 is, and print out the value for your average, and the total salary for Department 10 is, and print out the total salary. Now we'll pause for a moment. This is a great time for you to stop the recording so that you can do the exercise before we take a look at the answers. And don't forget to enable the buffer or you won't see your message. Okay, let's take a look at a solution to this exercise. First thing, notice we are going to be using DBMS output.putline, so it's important that we enable the buffer. This particular example is enabling our buffer with the set server output command. So we say set server output on. Notice this SQL plus command comes before the beginning of our PL SQL block. So at the beginning of our block, we start off with the word declare, and we're declaring a variable called average sal, and that looks like the salary column in the employee table using the % type anchoring. We've also declared another variable called sum sal, and this is being declared as number 12, 2, total of 12 digits, 2 of those 12 digits being to the right of the decimal. Now, we're ready for the body of the block. So that's signaled with the keyword begin. And here's our select statement. We very simply need to select the average salary, comma, sum salary into our two variables that we declared. And here they're listed, of course, in the appropriate order. It does this by position. This is being selected from the employee table where the department number equals 10. And then finally, using DBMS output.putline, we print messages. The average salary for Department 10 is, we concatenate that string with the value of our variable, average sal. And then in another call to DBMS output.putline, we send a message that says the total salary for Department 10 is, and we concatenate that string with our variable sum sal. Finally, we end the block, and then we use this slash here to actually execute the block. Do you have questions? If you do, please remember we have our question and comment box that you'll find located at the bottom of the page. Thanks so much for joining me, and I look forward to seeing you right back here in future modules.